Okay, here's a What the Physics video on friction. So we've got Mr. Reiter's packets, specifically this is his packet number 5 on friction, and we're going to work through some of his example problems because, you know, reading is difficult for some people, so I figured maybe making a video on this would be beneficial. So this one is going to be about using the fun equation. So it's example number 1. And of course we have learning targets. I can distinguish types of friction and solve for each using the fun equation. So we have a 0.17 kilogram hockey puck is sliding along the ice to the right, and nothing is touching the puck except the ice. The coefficient of friction is this guy here, and what is the force of kinetic friction exerted by the ice on the puck? So let's go ahead and start off by drawing out the free body diagram. So here is my puck, and remember, you can draw a box or you can draw a big thick heavy dot, whatever. I like to draw a box. So I'm going to draw out the forces acting on the puck. So there's the gravitational force, because if we're on Earth, there's a gravitational force. And then there's the normal force that is pointing upwards. Remember, we draw the free body diagram, so the forces are coming out of the object of interest. And then let's see, the object is sliding to the right. Now, I'm not going to really draw that into the FBD itself, but off to the side, I'm going to draw, like, there's a velocity that way. And if we're moving to the right, that means we're going to be accelerating to the left. Now you say, well, how do I know that? How do I know I'm accelerating to the left? Because the only other force acting on here is a frictional force. Friction always opposes motion, or at least for a sliding object. We'll get into more complicated stuff like with wheels and spinning things later on. Get rid of that. And so we've got this. Yeah, that's my free body diagram. The object is sliding to the right. So I don't need to create a new FBD for the components because there are no angled forces that I need to break down. So I'm going to try to deal with this equation here. Now, the only equation that we have that deals with coefficients of friction is going to be the fun equation. So we'll come back to that. I know for the fun equation, I'm going to, let's go ahead and write out the fun equation. Force of friction is equal to mu times force normal. And in order to use the fun equation, that means I'm going to need the mu, the normal, and the friction, or at least I'll be solving for one of those, right? So let's see. I have the mass of the object is 0.17 kilograms. I can figure out the weights from there. It looks like I need to solve for the normal force, though. So let's go ahead and do that. So my next step is making my list. Let's see. I've got the mass is 0.17 kilos. I don't know what my gravitational force is. That's question mark. I don't know what my normal force is. Also question mark. I don't know what my frictional force is. Yikes, I don't know a whole lot, huh? But I do know that mu is equal, and that's going to be mu kinetic, by the way, is going to be equal to 0.15. So you say, all right, good. Now what do I do? Well, let's go ahead and do that net force equation. Got that. Boom. Net force on the y equals mass times acceleration on the y. All right, good stuff. Am I accelerating on the y-axis? Is the puck floating up into the air or falling down? No, it's just moving along nice horizontally. So that means the acceleration on the y is 0. So that means my net force on the y, and the whole point of me drawing out the free body diagram is so I can see this. Normal is upwards, gravitational is downwards. That's it. Normal minus gravitational is equal to 0. Cool. So that means I can just add gravitational force to the other side, and I can say normal equals gravitational. Which, by the way, I don't know what that is, but I do know, wait, I do know gravitational force is equal to m times g. Yes, good. All right, and I do happen to know the mass. The mass is given to me as the 0.17 kilos, 0.17 kilograms, and And then I'm going to multiply by g, which I'll use as 9.8. Here you can also use 10 in some cases. I'll use 9.8 meters per second squared. So I'll go ahead and I'll tap that into the calculator, and I'll get normal force, which is equal to gravitational, is equal to 1.67 newtons. Okay, so both the normal and the gravitational are 1.67 newtons. Now, as you can see from the free body diagram, the normal force is 1.67 newtons upwards, and that's the normal. And gravitational is 1.67 newtons downwards. Okay, some people like to put in the negative signs here. I just figured the free body diagram is much better at taking that into account. Okay, good stuff. And now I'm looking for it says, what is the force of friction, right? So let me go ahead and solve using the fun equation. Force of friction. Oh, look, it's already rearranged for us. How lovely. Lovely, lovely. So that's going to be 0.15. Remember, there are no units on that. And then the normal force, which we just solved for, 1.67. And that's going to be in newtons. So I'll go ahead and multiply those together. And I'm going to get force of friction is equal to 0.25 newtons, because there's newtons right there. And that's going to be, the friction is pointing to the left here. So if I'd like to say to the left, although I think Beyonce was the one that said that the best, yeah, there's my answer. So hopefully we understand how we can use the fun equation here. I drew out a free body diagram. I listed out my variables. I said, oh, I'm going to use the fun equation because I've got the coefficient of friction. And so I had to solve for my normal force because I didn't have it originally. And then I solved for friction. Boom.